I'm coming. So the first force P has magnitude 8 and angle 30 degrees. What a lot of you actually missed was forgetting that for bearings and vectors, angular measurement is taken from the north. So I said that for bearings and vectors, angular measurement is taken from the north. So you need to take your angular measurement from the north. From the north or the y-axis. The north is also the y-axis. Okay, so I'm giving the vector or the force, which is a vector quantity of magnitude 8. 8 P is equal to 8 Newton, acting at an angle of 30 degrees. Now, I must first draw my cardinal point, indicating the north or y, and this is the south. Then we have here as the east, and then west. For bearings, angular measurement is taken from the north. Okay, so either you draw this as x and y axis or the north and south axis. Then 30 degrees from the north, meaning I must take my angular measurement from the north, an angle of 30 degrees. This is where the force 8 Newton will be directed. Now, once this is 30, these are complementary angles, and complementary angles add up to be 90. So once this is 30 degrees, the remaining angle is 60. Please, are you there?
Yes.
Are you there? Okay. So the remaining angle is 60 degrees, meaning I can resolve this using the angle 30 or resolve the force using the angle 60. The choice now is mine. Okay. And whichever way I look at it, I must get the same results. So we are going to look at using any of the complementary angles to get the components of the force 8 Newton. Now, if you use 60 degrees, the side that is opposite to this angle would be this part. And the side that is adjacent to the angle is this side. Now, this side from triangle law of vectors, this side is perpendicular. And because this side falls within the y-axis, north or y-axis, this part will be Fy. Then this component, the horizontal component, falls within the positive x-axis. So this will be Fx. In the same way, if I use the angle 30, okay, this side will be opposite to the angle. So this part of the vector, which is this side, will be opposite to this angle 30. So this side becomes the opposite. But then, because this side also lies within a positive x-axis, okay, this side is the same as this side. So this would also be fx. This side, which is adjacent to the angle 30, is also the same as this side. And so this will be fy. So if I'm using 30 degrees, sine of, if I take the sine of 60, sine 60 degrees is equal to opposite, which is fy, over sine is so opposite over hypotenuse. The hypotenuse is the vector p, the force p, 8. So fy is equal to 8 sine 60 degrees. Please, are you with me? Class, are you with me?
Yes, please.
Sir, please come again.
So I'm just looking for the opposite. And whenever you are looking for the opposite, knowing the hypotenuse, the obvious trig ratio is to use sine of the angle 60. And sine, which is opposite over hypotenuse, will be fy over 8. Therefore, the vertical component using the angle 60 will be 8 times sine 60. And this is sine 60 is equal to root 3 on 2. So 8 times root of 3 on 2, which is equal to 4 root 3. This will be 4 times root of 3 Newton for the vertical component. Let's look for the horizontal component. Let's look for the horizontal component. The horizontal component is this, fx. And once I know the angle and then the hypotenuse, the obvious trig ratio to use is to use what? What's the obvious trig ratio to use here? What will be the appropriate trig ratio to find the adjacent? Yes. Or the x. Good.
Cosine.
Good. So if I take the cosine of the angle, cos of 60, cos is adjacent fx over hypotenuse 8. So making fx the subject, I have fx equal to 8 times cos 60. Cos 60 is half. So I have 8 times half, which is equal to 4 Newton. Therefore, the component of the force P would be equal to, which is x on x and y, would be equal to 4 Newton and 4 root of 3 Newton. In fact, this 4 root 3 Newton, you can also express it as decimals. Now, if I use the other complementary angle, which is 30, let's use 30. if I use 30 and I'm looking for this side, fx, this is the opposite to this angle. So sine of 30 would be equal to opposite, which is fx over hypotenuse, which is 8. Therefore, fx is equal to 8 times sine 30. Sine 30 is equal to half, and so I have 8 times half, which is equal to 4 Newton. Then, if I need the adjacent of the angle, the obvious trig ratio is cosine. If I take cos of the angle 30, I have the adjacent, which is Fy over the hypotenuse, which is 8. Fy is equal to 8 times cos 30, which is equal to 8 times root of 3 on 2. 8 times root of 3 on 2 is equal to 4 root 3 Newton. So you realize that whether you take 30 or 60, P, which is x on y, would be equal to the same value. X is 4, and then y is 4 root of 3 Newton. So no matter how you look at it, if you do the right thing, you must get the same results. You must get the same results. Please, is that clear?
Yes, please.
All right. The second question. By the time we go through, we finish with all the 4, I'm sure you'll be well equipped. Q is equal to 10 Newton and then 120 degrees. Let's look at that too. So let me clear this solution. For bearings and vector quantities, angular measurement is taken from the north. It's not like trigonometry where we measure angles in an anti-clockwise from the X. No. Okay, so the next force is Q, which is equal to 10 Newton acting at 120 degrees from the north. For bearings, we are measuring our angles from the north. So let's draw the cardinal points. This is the north, east. And the angle is always taken in that clockwise direction. So I'm going to draw 120 degrees. This is 90. How much do I have to add to 90 to get 120?
30.
So I need to
30.
add 30 degrees to it to get 120. So from here, I measure 30 degrees. This is 30 degrees to the x-axis, and I have 10 Newton. So I'm using the equivalent angle is 30. The equivalent acute angle. This is the opposite. This is the adjacent. The opposite and adjacent are perpendicular. Now, two things. You see, I earlier said that if you are taking the angle from the north, the order of your components, if the angular measurement is from the north, the order of your component becomes sine, cos. If you are taking it from the x-axis, the north is the same as y-axis. So if you are using the angle the vector makes with the north, it should be sine, cos. If you are using the angle the vector makes with the east or x-axis, it should be cos, sine. So look at the order. I repeat, if you are taking the angle the vector makes with the y-axis, which is also the north, the order is sine, cos. If you are using the complementary angle, which the vector makes with the x-axis, the order is cos, sine. Please, are you with me?
Please come again.
You see, with the first example, P, when we took our measurement from the angle it made with the north or y-axis 30, then we also determined the complementary angle 60. For 60, we had 8 cos 60, and then 8 sine 60. When we use the angle it made with the y-axis, this is the force. The angle it makes with the y-axis, the order was 8 sine 30 times 8 cos 30. So all that I'm saying is that if you are considering the angle the vector makes with the y-axis or the north, the order is sine, cos. If you are using the complementary angle to the x-axis, the order is cos, sine. Class, are you okay? Are you okay?
Yes.
So that thing is very, very, very important. Now, I'm going to apply that to this. One way of doing this is that if I take my measurement from the y-axis or from the north, I have an angle of 120. So 120 degrees from the y-axis before I can locate the vector 10 Newton. So when I'm looking at the angle it makes with this y-axis, it is 120. So the vector can be 10 sine 120 and then 10 cos 120. This is because this is the angle it makes with the y-axis. And so the order is sine, cos. Now, so I can resolve it using this. I can also resolve the same force using the corresponding angle 30 degrees. This 30, it makes with the x-axis. Okay. Now, when I want to use the angle it makes with the x-axis, which is this. The adjacent would be 10 cos 30. This is fx. This is fy. So if I take cos 30, adjacent over hypotenuse. So cos 30 degrees is adjacent, which is fx over hypotenuse 10. If I make fx the subject, I have 10 cos 30, and that's what I've written here. Are we okay?
Please, can you come again?
Yeah, please, can you go over?
So watch carefully. So apart from the 90, the angle it makes with the x-axis is 30, meaning 90 plus 30, I get 120. So I can determine the component also using 30 degrees. When I use 30, this is the opposite side, this is the adjacent. So if I'm looking for the adjacent, I use cosine. So cos of this angle, which is 30 degrees, is equal to the adjacent, which is this side, fx over the hypotenuse, which is 10. If you make fx the subject, we have 10 times cos of 30 degrees. And that is the x component. If I'm looking for the vertical component, this is the opposite. If I take sine of 30, opposite, which is fy over hypotenuse 10. Fy is equal to 10 times sine 30. Now, the other thing to pay attention to is this. Within this quadrant, whenever you move from the first quadrant, this is the first quadrant, 1, 2, 3, and 4. So first quadrant, second quadrant, and then the fourth quadrant. Within the first quadrant, all trig ratios are positive. Whether you take sine, cosine, or tangent, they are all positive. When you come into the fourth quadrant, look, in your transformation, this is a negative y. This is negative x. This is positive. The north is positive y. And then the east is positive x. So if I determine x is positive, because this is positive x, so any measurement along this direction is positive x. If I determine fy, I'll measure fy from here to here along the negative y. So fy, in this particular case, fy will be negative. So fy must be equal to negative of okay, this is negative because it's along the negative y-axis. So any measurement below x over here is negative. So for this component, x is positive, fx is positive, this is positive, and fy is negative, minus this. Please, are you okay? So
Please.
the result, you ask, we'll be doing the same thing as we move on. So cos 30, fs, which is 10 cos 30. Cos 30 is root 3. Cos 30 is, as Josiah, I'm coming, is a root 3 on 2. So I have 5 root of 3. Then fy, which is 10, negative 10 sine 30. Sine 30 is half. So we have minus 5 Newton. So these are the components of 10 sin 10 Newton acting on 120. Josiah, what's the question? No, Josiah, your line is breaking. Josiah, reconnect and come again. Your line is breaking. So all that I'm saying is that because this is y negative x positive x, every measurement which is below or along the side would be negative. When it is along here, it will also be negative. But when it is here and it is here, it is positive. This is the reason why all trig ratios are positive here. Okay, because this is positive y, positive x. So any angle here, when you take the trig ratio, must give you a positive value. So we can find the component using the angle it makes with the north or y. Hello.
Yes, please. I wanted to ask, why are we using sine 30 and cos 30 instead of the angle that was given in the question?
Good. And I used it. That's it. That the earlier value I did was that the angle it makes with the north is 120. So whenever you are taking the angle it makes with the north or the y-axis, it can be sine cos. So 10 sine 120 and then 10 cos 120. But this is the same as when you use the acute angle 30 degrees as well. Determine the value of 10 sine 120. Find out for me. What is 10 times sine 120? You get the same value as this. 5
Yes, please.
3.
to 3.
Yes,
Good. And 10 cos 120 is also the same value as negative 5.
Minus 5.
Good. So what I'm saying is that the 120 will do it, but I'm giving you other methods as well. Okay.
Okay. Okay, yes, please.
Josiah, are you
Alright.
back? There's another method. There's another method. And open your eyes to see it. I am giving you all the tools you need. The other method is this. If this is 30 degrees, what is the remaining angle to the y-axis? What's the
60
remaining? 60.
60 degrees.
Good. So the same vector 10 makes an angle of 60 with the y-axis. Don't forget, I said when we are looking at the angle it makes with the x and y-axis, the other will be sine cos. If we are looking at the angle it makes with the x-axis, it is cos sine. So look at something. This is the angle 60. The opposite to this angle would be this side. And then this is the adjacent. This is the opposite, but the opposite falls within fx. So this length is the same as this, so we'll call this as fx. Now, the adjacent, which is also here, is the same as this side, so we'll also call this fy. Please, are you following? So if this is the order,
Yes.
if I need fx, okay, once this angle is opposite to it, I'll take sine of the angle 60, and it is equal to fx over 10, the hypotenuse. Fx is equal to 10 sine 60. If I need the adjacent, which is Fy, I'll take cos of the same angle 60. And it is also the adjacent Fy over the hypotenuse 10. Fy is equal to 10 cos 60 degrees. But with this method, you don't have to overlook something. You see Fy, the adjacent. The adjacent is along the negative y-axis. So you must, it means that every value here along this line is negative. You got this negative y. So quickly, Fy must be negative. It must be negated. As for the x, the adjacent is along the positive x. So that is positive. But the y is negative. The reason for which Fy is negative. So this is equal to sine 60 is root 3 on 2. So 5 root of 3. Cos 60 is half. This is negative 5. Please, is it different from the other answers we had? Is it different?
No, please.
Au revoir, what is your concern?
Mr. Area, please, I wanted to ask. What if what you are solving for in the Fy, you get a positive number, you have to still negate it because it's on the negative y-axis.
Yes, if you don't use the angle that was given direct, the 120, and you use the corresponding angles, then you must factor the direction of the component where that component lies. You must decide, is it falling along the positive or along the negative? If it falls under the negative, you must factor. But if you use the main angle, it takes care of itself. Are you okay?
Yes, please.
Let's solve the other examples. R. See, we are given 15 Newton at an angle of 210. So as we go through, it will bring the understanding well to all of you. And anyway, we had not discussed this, so I knew that a lot of you would miss out on that. It was actually a way to test how you can further read. So the other question, R is equal to 15 Newton acting at R is equal to 15 Newton acting at an angle of 210 degrees. The guiding rule is that for vectors, angular measurement is taken from the north. So if you are drawing, that is how you must see it. So my X and Y are not and south. North, north, south, east, west. I must measure my angle from the north. 120, this is 180. What should I add to 180 to give me 210? What should I add to 182? So 30 from, so this is 30. So it makes, this is negative y. It makes an angle of 30 degrees with the y and makes an angle of 60 with this x. And the vector is here. Its component is 15 Newton. Without taking account of acute angles, once the angle it makes with the positive y is 120, 210, the other can be sine cos. So 15 sine 210 degrees, and then 15 cos 210 degrees would give me the answer direct. And this is equal to, yes, what is 15 times sine 210? It must be a negative value.
Negative 7.5.
Negative 7.5 Newton. And this is also negative
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 12.990.
So how did I do this? Once I'm considering the angle it makes with the y-axis, the other will be sine cos. So this is one solution. So I think is it a refer you ask? I've taken care of the angle that was given. The other way out is this. I can also use the angles it makes with the x and y. If I use the angle make the vector makes with, or the force makes with y, which is 30. This is how I'm going to do it. For 30, this is the opposite. And then this is the adjacent. So the opposite is here. This is Fy. Fy because it's along the y-axis. And this side is Fx. Fx because it's also along the x-axis. Please, are you with me? Are you with me?
Yes, please.
All right. So if I want this, I need to take this the adjacent to this angle. So cos of 30 degrees is equal to Fy, which I don't know, over the hypotenuse 15. Fy is equal to 15 cos 30. Now, is Fy positive or negative? From what we have, it's Fy is along the negative y-axis. So put that there. Negative. So it means that Fy with minus 15 cos 30 is root of 3 on 2. So I have minus 7.5 root of 3. And what is minus 7.5 times root 3? Yes.
12.99.
Good. So Fy is equal to minus 12.99 Newton. Let's look for Fx. Fx is here, is opposite to the angle 30. So when I take opposite sine of 30, please let me change the marker. If I take sine of 30 degrees, sine 30 is opposite, which is Fx over hypotenuse 15. Fx is equal to 15 sine 30. Now look at the position of Fx. Is it positive or negative? Is Fx here positive or negative?
Negative.
So put it there, negative. Sine 30 is half. So I have minus 7.5 Newton. So when you arrange this in components, coordinate x, y, you realize that the x component is minus 7.5. The y component is minus 12.99 Newton. Is it different from when we use 120? Class, is it different from when? No. Okay, try it with the angle 60 degrees. So for 60 degrees, this is the opposite. Opposite of the angle, which is Fy. Because it has to be the same as this. And this is the adjacent, Fx. Try it with 60 and let's see. I want to take a shot of attendance and then drop it into the group. So do it whilst I also do that. Is that okay?
Yes, please.
So are you true?
Yes, please.
Did you get the same results?
Yes, please.
So please let me hear it from all of you. Did you get the same results?
Yes, please.
So these are the different ways of doing the same thing. Let's quickly look at 12 Newton, 330 degrees, acting at 330 degrees. I can use the angle it makes with the north or y axis direct, 330. But don't forget that because this angle is to the y axis, the order of the component must be sine, sine. If it is cos and sine, it means you are taking the angle to the x axis. But once it is to the y or the north, it must be sine and then cos. So you are talking about S, which is equal to 112 Newton acting at 330 degrees. So if you understand what you are doing, then the component X and Y components would be equal to 12 sine 330, 12 cos 330. And this would be equal to, yes, what is 12 times 330?
-6.
So this is exactly -6 Newton. And then cos 12 times cos 330.
10.3.
6 root of 3.
22.3.
No, 10.39.
10.392.
Oh, okay. 10.392. Okay. 10.392. So approximately 10.40 Newton. So we are going to consider the other methods to confirm the same thing. So let's draw our X and Y. In bearings, angular measurement taken from the north in a clockwise direction. So the whole of this is 270. I must add 60 degrees from the X axis to get, so this is 60 degrees. And this is also 30 degrees. Leslie, go ahead.
Mr. Yeah, please, I wanted to ask that when you are giving the question, do you have to draw the Cartesian plane?
If usually when you draw, it makes you see better, especially if you are using the components force or the corresponding angles. The corresponding angles to do. If you are not using, if you are using this, there is no need of drawing. If you are using the angle it makes with the y-axis or the north, there is no need of drawing. But if you are using this method, it will help you to see better. So there is a need for you to draw. Okay.
Yes, please. Thank you. Yes,
All right.
please. Thank you.
Okay. So if you use 60, this side becomes the opposite side to the angle. And this, because it's along the y-axis, this becomes Fy. And this side becomes Fx. Now, to determine Fx, cos of 60 is equal to Fx over 12. Fx is equal to 12 by cos of 60. But look at Fx. Is it positive or negative? It's F.
Negative.
Please, negative.
So you must quickly put that there. Negative. This is equal to cos 60 is half. So you have minus 6 Newton. Then the vertical component. Sine of 60 is equal to opposite Fy over hypotenuse 12. Fy is 12 times sine 60. But look at where Fy is. Is it positive or negative? Is it along the positive or negative?
Positive.
This is positive. So you leave it as it is. Fy therefore is sine 60 is root 3 on 2. So 6 root of 3 Newton. And you can change 6 root 3 into decimal figure. So the components we have minus 6 Newton and 6 root of 3 Newton, which is actually the same as 6 root 3 is the same as 10.4. Therefore,
Stay there.
I'm listening.
Please, I wanted to ask that. I see where you draw the Cartesian plane.
Mhm.
Where the F is using the angles that they gave us. To find the x axis, you use sine, but when you use the 60 degrees, you use cos. I wanted to ask why.
That's why I'm saying that. You see, if I'm using the angle that was given to us, how would I measure it? I measure it from the y-axis because my angular measurement will start from here, isn't it? From the
Yes, please.
y-axis. So I'm taking my angle from the y. And whenever you are measuring your angle from y, the order of the component must be sine cos. If you are taking your component from the angle it makes with the x-axis, this is y. For x, it must be cos sine. That is why over here, you see, look at my x component, fx. Fx is equal to minus 12 cos 60. And then the Fy is 12 sine 60. And this part confirms it. This part confirms that if the angle is to the x, it is cos sine. If it is to the y, it is sine cos. Therefore, is it understood?
Yes, please. But I wanted to ask again. Using the angles that they give us, when we draw the vector on the Cartesian plane, should we like fix it in with the 60 so that we can use the cos 60 to find it, or we should just go ahead with it like that
You
with
can
the angle given?
you can use the angle given to you to get the component, or you can resolve it into it corresponding angles. Corresponding angle, the 60 and 30. But both ways must give you the same results. Okay.
Yes, please.
So from what I am teaching you, I'm giving you the different ways of doing the same thing. Don't forget, we are left with this angle. It makes with the y-axis. I want you to try. Let's see if you can get the same answer. The angle 30 degrees, it makes with the y-axis. So this time, this side will not come in. We are using the angle it makes with the y, which is 30. So this is the adjacent. Sorry, the opposite to this angle, and this is the adjacent. So the triangle law of vectors must be followed. So use this. Let's see if you get the same results. Just make me proud. Start with. Are we through? Are we through? Hello?
Hello.
Are you through?
Yes.
Yes, please.
Did you get the same thing?
Yes, please.
So that's the beauty of this work. Okay, that's the beauty of it. All right. Now let's solve a question. And listen to the question. I'm reading it to all of you. Two forces of magnitude. So we have two forces. Let me give you the two forces. We have two forces. 10 Newton acting at 60 degrees. So two forces F1. Its magnitude is 10 Newton acting at an angle of 60 degrees from the north. And another force, 6 Newton, the second force is F2. 6 Newton at 330 degrees. They act on a body. So these two forces act on a body. Find the magnitude and direction of the resultant. Find the magnitude and direction of their resultant. So we have these two forces. You have to find the magnitude and direction of their resultant. Now, one way of doing this is they act on a body, the same body. So it can be a drawing, but let's draw the cardinal points to indicate the direction of the forces. This is F1 acts at 60 degrees from the north. So this is 10 Newton. The angle between the x-axis and the vector is 30. The other force acts at 330 from the north. So this is 60 degrees from here. So this is 30. This is 60. It simply means that The two vectors are 90 degrees apart. So I can use Pythagoras theorem even to find their resultant, because the angle between them is simply 90 degrees, 30, 60. So I can use even Pythagoras theorem to find the resultant, as we've learned before. Okay, as we've learned before, we can do that. But another way of doing the same thing is resolve this into components. The x and y component of f1 becomes, this is 10 sine 60 degrees. And then the y component is also 10 cos 60 degrees. Or you can also use the angle to the x-axis. Please, are you with me? Are you okay?
Yes, please.
And this is 5 root 3. This is also 5. Then let's pick the other one. The other one can be directly 8x and y components will simply be 6 sine 330 and 6 cos 330, or the other ways we have studied. Find 6 sine 330 for me.
-3.
-3.
Okay. So this is -3. And then 6 cos 330.
3 root 3.
Okay. Now, you see, we have resolved both F1 and F2 into components. Okay. Then the other way to determine the resultant is that find summation of all Fx. F1 has 8x components. So F1x plus F2 has 8x component, F2x. So this is equal to F1x is 5 root of 3 plus -3. So this is -3. And then find summation f of y, which is f1y plus f2y. And this is also equal to f1y is 5. f2y is 3 root of 3. So help me find 5 root 3 minus 3. Give me the value in 3 dp. What is 5 root 3 minus 3?
5.660.
5.660. Okay. So 5.660 Newton. Then 5 plus 3 root 3.
10.196.
Come again.
10.196.
So approximately 10.200. You see, so we have found summation of, for all the two, or if you have more of them, more vectors, you have summation of all the x's, summation of all the y's. When you finish, because you are asked to find their magnitude and direction, this is what you do. Draw whatever you've had on the Cartesian plane, x, y axis. Look at what you had for summation x. This is the x axis. This is the y axis. Summation x is positive, meaning it will be along the positive x. So this is summation fx, which is 5.66. It's positive. The reason for which we are placing it on the positive x-axis. If it had been negative, it will change. Now, summation y is also a positive value. So it has to be placed on a positive y-axis. So it is here. This is summation fy. Its value is 10.20. Now, this is what we have. We have two vectors. One, let me clean this side and draw your attention to something. We have two vectors, one going up and one going due east. So if you have these vectors, how do you determine the resultant of them? If you have
By
this,
Pythagoras theorem.
but before then, what do you have to do?
We have to resolve it.
No, we have resolved it. The reason for which we have the x and y component. But if you have two vectors in this manner, how do you determine their resultant?
You have to draw the equal vectors of x and y.
Good. So as you do so, what are you doing? You are realigning their direction, because this direction doesn't make sense. You can't determine where they are going. So the equal vector approach realigns their direction. So this is here and this is here. Even doing it once will tell you, okay, then the other direction will be here. So this becomes the resultant. So when we apply it to what we have, summation y is 10.20. This is its direction. This is x direction. When you realign the direction, you can find the resultant which will act in this direction. And you can now use Pythagoras theorem to find the resultant. So let's use Pythagoras theorem to find the magnitude of the resultant. The magnitude of r squared will be equal to summation of fx squared plus summation of fy squared. What is summation fx? Is 5.66 squared. What is summation fy? 10.20 squared. R therefore will be equal to the square root of 5.66 squared plus 10.20 squared. Calculate it and give me the final answer. What's your final answer? Hello, what's our final answer? Hey,
136.075.
136.075.
136. Eh?
Yes, please.
136.076.
136.075.
Because I'm getting 11.665.
Yes, please. That's the square root of 136.076.
I mean the final answer, not.
Yes, please. It's 11.665.
So this is the magnitude of the resultant. That's the resultant when the two forces act in that manner. Now direction. Once we have this, look at where the resultant is heading towards, is moving up. So the angle it makes with the x-axis becomes its direction. Once I have the opposite, which is summation f y, and we have the adjacent, I can use tan. Tan of theta. And theta is the angle of the direction. It's equal to opposite, which is 10.20 divided by adjacent, which is 5.66. Theta therefore is equal to the tan inverse of this ratio. Find it for me.
1.80.
Have you taken the tan inverse? Have you taken the tan inverse? So the tan inverse is press on shift, then look for tan, T-A-N. And then
60.9.
so the angle is approximately 61 because it is 60.97. So theta is approximately 61 degrees. That's the direction. So the resultant acts at 61 degrees from the east or 61 degrees. Look at it. 61 degrees from the east is the direction of the resultant, or this whole angle is 90. So if I'm measuring it from the north, I must subtract 61 from 90. So or 90 minus 61. Okay. So 61 degrees from the east from the east or x-axis or 29 degrees from the north. The direction, either you take it from the east or x-axis anti-clockwise, or you take it from the north clockwise. So that is how we are. So with this understanding, if you are given about 5, 10 forces acting on a body at the same time, the trick is that pick each one at a time and then resolve it into its vertical and horizontal components, X and Y. When you finish, sum up all the X's, summation of all X's of all the individual forces, then summation of all the Y's. Okay, then you redraw. Look at their magnet value, their values, and you redraw as this. You are good to go. That's just the approach. Any question? Any question? Jojo, are you there?
Yes, sir.
Okay. Leonard.
Sir.
Are you there? Please, is it well understood?
Yes, sir.
Because I'm going to send you examples to try. It's not difficult. But once you understand how to resolve forces into components, that's all. You can easily apply it and then. Okay, let me send you a question. And I'm going to drop it on the platform. And this time, I'm going to give you about 5 forces